Hey, Weather Warriors, hope you're having a great day. A rather significant event is unfolding here in the plains. A potential tornado outbreak is possible in parts of the plains and also a major winter storm. We're going to talk about the outbreak and also the storm in this video. What we're looking at is the jet stream. Look at this bowling ball trough. There's a strong jet streak, winds of in excess of 100 miles an hour coming out of Mexico. This is causing some serious divergence in the atmosphere, a really good setup for a strong low pressure system and outbreak. We're going to first look at the severe weather because that is not too far from now. This is the dew points. Okay, this is the moisture coming out of the Gulf of Mexico. These barbs essentially mean it's coming out of the southeast, is riding right up into the Oklahoma and Texas panhandle. You don't really see any fronts, distinguished fronts yet right now, but watch as we get towards around 4 p.m. or so. That moisture starts to scoot north. Here's your moisture axis running right through central Texas into Oklahoma and the panhandle. And you're going to get a frontal boundary right here that develops and sparks off some potential storms up near the triple point here in the Texas panhandle in Oklahoma, particularly where you see these winds go from southeast to east. That is a concern because it adds wind shear and essentially kind of rotation in the atmosphere for potential tornadoes. Right around 4 or 5 p.m., storms blow up in the panhandle and then move east, and you can see this frontal boundary shifting to the east, but I do think there'll be some weakening as it does. Now we'll look at the jet stream. If you want thing I want to show you here is look at the jet stream up here. It's moving southeast or southwest to northeast. If you go to looking at the surface plots here, the jet stream is moving southwest to northeast. It's moving right across this boundary. Because of that, these storms that blow up on the boundary, they go right into this warm, moist air mass. So they're blowing into a warm, moist air mass. That is important because it raises the significant severe weather potential. One other thing we look at for severe weather is instability. This measures the buoyancy in the atmosphere. If it's really hot at the surface and really cold aloft, well, that warm air is going to rise really rapidly. So we're kind of looking at that essentially, a snapshot of how fast that warm air is going to rise. You can see at 4 p.m., we got lots of instability here for this time of year out in Texas, Oklahoma, about 1,000 to 2,000 Cape, particularly along the panhandle. Lots of instability right over where that jet was and right where that frontal boundary is. Those are 3 different ingredients that are coming together for potential severe weather. This is Saturday at 7 p.m. You can see it really starts to weaken right after sunset. In the summer, it's usually more forgiving because you have like 5,000 Cape and you can ride it out throughout the night. But because it's kind of early in the year, we just don't have a whole lot of instability there to work with, and it really dies out right after sunset. And so I think the severe weather threat's going to diminish on the east half of Oklahoma and Texas overnight. Not going to be nearly as strong. If you look at the 0 to 3 km Cape, now what is this? Well, this is the instability at the low levels of the atmosphere from the surface just to off the deck. This is important for tornado development because it's kind of where tornadoes form is in the low levels. And if you have a lot of instability or buoyancy in the low levels, that increases the tornado potential. Here's 4 p.m. and you can see lots of instability in the low levels out here. I mean, this is a significant amount right now. And this is around Texas panhandle. It's right in that same zone. So we got a lot of things coming together. This is 4, 5, 6, and now 7, 8 p.m. You can see it. There's still a little bit from south central Texas, Kansas into north central Texas. And then overnight, it does move east. There is a little bit of low-level instability, so this would be something to watch, but I think it's going to be mostly a messy, rainy event by then. This is the cap in the atmosphere. So when is things supposed to break here? Well, the cap is preventing, it's like a warm layer aloft, preventing air from rising, essentially, because it's warmer above in one little layer. And you can see a big significant cap in the colors there. But as we head towards the afternoon, this is around 2 p.m. or so, the cap begins to break. Now, storms will take an hour or two to develop, but around 4 p.m. is really when that cap breaks out in the panhandle and of Oklahoma and Texas, and then it starts to kind of build again in some areas later in the night. Here's the supercell composite. What are the odds of supercells developing? Now you'll see right now it's enhanced here in parts of New Mexico. The issue is the caps preventing those thunderstorms from developing. So even though the supercell composite shows stuff, it might not occur as far southwest as where it shows here. But as we go towards 4 p.m., boom, supercells possible in the Texas Panhandle. We got amounts as much as 30 supercell composites, so pretty high. To the south of there, it might be more linear. As we head towards 7 p.m., you can see this moves to the east, actually enhances a little bit in southern Texas. Significant tornado parameter. This is at 4 p.m. Look at that, pretty enhanced over there in the Texas Panhandle. So this is the measuring the chances for tornadoes. All we really need is about a 1. This is all the way up to almost, in some areas, well over a 10. Actually, that'd be the supercell composite, so that's over a 30, but we'll look at the significant tornado parameter real quick here. So you can see some amounts are over a 4 or a 5, and that is pretty significant. All you really need is a 1. That's Amarillo, Texas Panhandle, Oklahoma Panhandle, and then that moves to the east. But you can see it really weakens overnight, and that's due to that weakening of the instability. The wind shear is still fine, but the instability really weakens. You will look at the wind shear real quick, and this is pretty remarkable. This is around 4 p.m. The wind shear, 70, 80 knots. All you really need for severe weather is about 30, 40 knots. And then overnight, that moves to the east. And there's still plenty of wind shear in Oklahoma and Texas in the east half. The issue is the instability really begins to weaken. Now, how does it look at the surface? We're going to look at the composite reflectivity. And I'm going to show you snowfall amounts real quick here. And this is when things could get going. Around 3 p.m. in the Texas Panhandle, the SPC has a 15% hatched, which indicates moderate potential for tornadoes and some potentially strong ones. So we could see some long-tracked, strong tornadoes. With that 110 knot jet streak, we could see speeds of 55 miles per hour in storm motions. And because of that, these could be long track tornadoes because they're moving so fast, the storm motions. And so that is something we have to watch here. Right in the western part of the West Texas Panhandle, they develop around 3 p.m. and then 4, 5 p.m. Look at that right there. That is a supercell, and supercells are much higher potential for tornadoes because they do have that rotational environment. A line, it's harder to get things to rotate like that. With the supercell, you can get a mesocyclone, essentially those laminar-looking boulders in the atmosphere that you see over the internet sometimes. That's essentially what you're going to get with these supercells. And it really blows up in the Texas Panhandle. They race to the northeast at 55 miles per hour. Look at those, 5, 6, 7 supercells right there. Really across the entire Panhandle. And then as we head towards around 7 p.m., they move to the east, but along that frontal boundary. So this is what I'm talking about when I say that storms blow off the frontal boundary. The cap's still pretty strong here, but the jet stream is blowing these storms off the boundary. And because the cap's strong, the storms are not developing everywhere yet. Just a couple develop, and because of that 55 knot jet, they blow off the boundary. That sets the stage for recovery just to the west, where more storms can develop. And when that cap really breaks down, storms blow up all at once. And that's why you get this linear type of look squall line that develops around 7 p.m. That moves to the east around 6, 7, 8, and really starts to weaken. But when they're linear, the tornado threat is much lower. So the best bet, again, Texas Panhandle, Oklahoma Panhandle, and West Oklahoma. And then as it moves to the east, more of a rain threat. All right, guys, and one more thing. This is the latest high-res model for the Northern Plains, Central Plains. We're talking with this snowstorm potential for 1 to 3 feet in southeast Wyoming, northern Colorado, western Nebraska, and southeast South Dakota, southwest South Dakota, and some areas could clock in at 3 to 4 feet in southeast Wyoming, as I mentioned in the past couple of videos. And then the HRR has pretty significant amounts. We're talking like 50 inches or so. So All more updates, guys, click the subscribe button below, comment below, and hope you have a great day.